Welcome to the deep dive. Today we are digging into the legacy of James Watt, the engineer on the 50-pound note, often called a founding father of the Industrial Revolution. We've gathered quite a bit of research on his achievements, his setbacks too, some surprising luck, and really crucial partnerships. Our mission today is to sort of weigh it all up. Was James Watt Britain's greatest mechanical engineer? Or maybe was he just the most momentous? Big difference there.
That distinction is absolutely key because right off the bat, we need to clear up a common misconception. James Watt did not invent the steam engine.
Right, that comes up a lot.
Yeah, the credit really goes back much further to Thomas Avery and especially Thomas Newcomen. Newcomen had a working engine pumping water back in 1712, long before Watt.
Okay, so Newcomen engines were around. What were they like? Why weren't they, everywhere already?
Well, they were what we call atmospheric engines, low-pressure condensing designs. They didn't use steam pressure to push the piston up or out. Instead, they created a vacuum by condensing the steam inside the cylinder. Yeah, so the outside air pressure of the atmosphere actually pushed the piston down. It sounds a bit backwards, but is mainly about safety.
Safety, how so?
Early metalworking, especially welding joints on cylinders, wasn't great. Trying to contain high-pressure steam was just asking for trouble. Bang, These atmospheric engines using a vacuum, they kind of failed inwards if they failed at all. Much safer.
Okay, got it. Safer, but you mentioned they weren't everywhere. So what was the big problem Watt saw? The thing you thought, hang on, I can fix this.
The Achilles heel was fuel efficiency, or rather, the lack of it. They were incredibly inefficient.
Why?
Because to condense the steam and create that vacuum, they squirted cold water directly into the main cylinder.
Ah.
So every single cycle, the cylinder walls got chilled right down. Then, when the fresh hot steam came in, a huge amount of its heat, its energy, was just wasted reheating the metal cylinder itself. They just devoured coal. And that's where Watt's genius comes in. It's actually quite elegant. His big idea around 1765 was the separate condensing chamber.
Separate, so not inside the main cylinder.
Exactly. He figured out why cool the whole working cylinder. Instead, pipe the used steam off into a different separate container and condense it there with the cold water. Keep the main cylinder hot all the time.
That sounds, well, almost obvious in hindsight. But the impact wasn't simple, was it?
Oh, it was revolutionary. Instantly, Watt's basic engine design was twice as fuel efficient as the very best Newcomen engine out there. Just like that.
Wow.
And we think his friend, chemist Joseph Black, helped him get to that aha moment. Black had recently discovered something called latent heat.
Okay, chemistry flashback time. Latent heat, remind us, why was that discovery so important here?
Right, so latent heat is basically the hidden energy that's absorbed or released when something changes state, like water boiling into steam without its temperature changing. Black helped Watt understand that when steam condensed back into water inside the cylinder, it released a massive amount of this latent heat.
And that heat just went straight into the cold metal walls.
Exactly. Wasted energy. The separate condenser stopped that energy bleed. Simple, but profound.
The idea was brilliant, no doubt. But the sources we looked at show it almost didn't happen. He had the idea in 65, but struggled for years, like 5 years, just to get a working model. What was stopping him? It wasn't the theory.
No, it was purely practical. Manufacturing. He needed the piston and cylinder to fit together with incredible precision, much better than anything local Scottish blacksmiths could manage at the time.
Why the precision?
For the vacuum to be effective, he needed a really, really good seal. Any leaks weakened it. His first partner, John Roebuck, funded him, gave him access to an iron foundry, but they just couldn't get it right.
And then disaster. Roebuck went bankrupt in 1774. But that failure actually became Watt's big break, didn't it?
It does make you pause, though. If the invention needed so much outside help and luck, does that affect his claim to being the greatest?
I think it has to, yeah. It highlights the importance of context and collaboration. The rescue mission was led by Matthew Boulton, a major English industrialist. Boulton took over Roebuck's patent share as part of the bankruptcy debt.
And Boulton was different. Oh, completely. He had the money, the business sense, a huge, sophisticated factory, the Soho Manufactory near Birmingham. He had everything Roebuck lacked. But even Boulton hit the same wall initially, the precision problem. The breakthrough came because Boulton knew of someone, a man named John Wilkinson, Iron Mad Wilkinson, they called him.
Iron Mad.
Yeah. He developed this incredibly accurate method for boring cannons. Perfectly straight, perfectly round bores. Boulton had a flash of insight. That cannon boring technique was exactly what Watt needed for his engine cylinders.
Wow. So Roebuck going bust, Bolton stepping in, Wilkinson having this very specific cannon tech. It's an incredible chain of events.
Pure serendipity, really. Without that specific sequence, the separate condenser, Watt's great idea, might have just stayed on a shelf somewhere. Amazing luck.
So with Wilkinson boring the cylinders, Bolton managing the business, the partnership finally took off. And they were smart, or maybe ruthless, about protecting it. They got Parliament to grant a massive 24-year patent extension in 1775. Gave him a lock on the market until 1800.
A quarter-century monopoly, essentially. And Watt didn't rest on his laurels. He kept improving the engine during that time.
What were the big improvements?
The main one was the double-acting engine, patented in 1782. This was a significant step up.
How did that work?
Instead of just using atmospheric pressure on one side, they cleverly engineered it so steam pressure acted alternately on both sides of the piston. It pushed and pulled, effectively.
Making it smoother, more powerful.
Both. And much more efficient again. About 5 times as fuel efficient as a standard Newcomen engine by then. It also allowed for rotary motion much more easily, which opened up factory applications beyond just pumping water.
But the sources we read throw a bit of shade on who actually invented these later improvements. It gets a bit controversial, doesn't it?
It does. Things get murky after about 1779. There's a strong suggestion, backed by some evidence, that William Murdoch, who was Bolton and Watt's brilliant chief engineer, was the real mind behind many of the later innovations, including key parts of the double-acting engine.
So Watt patented Murdoch's ideas.
Well, Watt was the partner. Murdoch was the employee. So legally, the patents went under the Bolton and Watt name, often filed by Watt. We know Watt definitely invented the parallel motion linkage, a really clever bit of geometry, but for the double-acting engine, well, there are even whispers that Watt's son later destroyed letters to obscure Murdoch's contribution and protect his father's legacy.
Paints a complex picture of the partnership. Successful, hugely influential, but maybe not always completely straightforward in attributing credit.
That seems fair to say. It adds weight to the momentous rather than perhaps purist genius's argument.
But Watt wasn't just steam engines, right? He had other inventions.
Oh, yes. His other big commercial success, totally separate, was the copying press from 1780.
Like a photocopier.
Sort of the 18th century version. It used special ink, dampened transparent paper, and pressure to create a mirror image copy. It was ingenious chemistry and mechanics combined. It became the standard way to copy documents for about 100 years.
That's incredible. Anything else?
Much later in life, he designed an articulated water main for crossing riverbeds, apparently inspired by watching a lobster's tail move. Clever guy.
Okay, let's pivot back to this greatest versus momentous question. What holds Watt back from being unequivocally the greatest? His character seems to play a big role.
Definitely. The sources paint him as intellectually brilliant, no question, but also deeply cautious, a lifelong hypochondriac, prone to depression. And that caution had real consequences.
Oh, so?
His biggest blind spot, or perhaps fear, was high-pressure steam. He was terrified of boilers exploding. Remember the early manufacturing issues? He never really got over that fear.
Even when metallurgy improved?
Even then. And this is crucial. William Murdoch, his own engineer, actually developed a working high-pressure engine prototype as early as 1784.
So Watt's own team had the next big thing, and he blocked it.
Essentially, yes. Watt refused to let Bolton and Watt commercialize high-pressure steam. He thought it was fundamentally too dangerous. This decision probably held back Britain's adoption of more powerful, efficient high-pressure engines for a decade, maybe more.
Wow, that's ironic. The steam pioneer holding back steam progress.
It is. And think about the lifespan of his own key invention, the separate condenser.
How long did that dominate?
Its heyday was surprisingly brief, maybe 30 years in practical terms. Once Watt's patents expired in 1800, inventors like Richard Trevithick jumped in. Trevithick patented his high-pressure engine in 1802.
And Trevithick's was better.
Fundamentally, yes. It was smaller, lighter, more powerful per unit size, and ultimately more versatile than Watt's low-pressure condensing engines. Watt's masterpiece was made obsolete relatively quickly by the very technology he resisted.
Okay, so an invention with a limited lifespan, and he actively slowed down the next step. Why on earth is he still considered so incredibly momentous? Why name the unit of power after him?
Because the impact during that period of dominance was colossal, and it comes back to that caution, ironically. Bolton and Watt's 25-year monopoly, combined with their meticulous engineering and quality control, meant the transition to steam power happened on a massive scale, but also safely.
Safety.
Crucially. Imagine if dozens of less careful manufacturers had rushed in with shoddy, exploding high-pressure boilers in the 1780s. Public backlash could have killed steam power adoption for decades. Boulton and Watt ensured stability and reliability. Their careful, professional approach built trust and allowed Britain to develop this huge engineering capacity and infrastructure around steam. That foundation was critical for Britain's industrial dominance. So the way they implemented it was arguably more historically significant than the initial invention itself.
So the business practices, the quality control, the sheer scale enabled by Boulton were just as important as Watt's initial spark of genius.
Absolutely. Watt was brilliant, praised by top scientists like Humphrey Davy, but his poor health and cautious nature meant he needed Boulton's drive and organizational skill. It was the partnership that was truly momentous.
And we can still see traces of this journey today, right? Where can people connect with Watt's story physically?
Oh, definitely. You can almost follow his path. In Glasgow, you can visit Glasgow Green. There's an inscribed boulder marking the approximate spot where he supposedly had the eureka moment for the separate condenser while out for a walk.
A walk that changed the world.
Quite possibly. Then up in Bowness, near Edinburgh, there's Keneal House. His old workshop is still standing behind it, pretty much unchanged. They even found some old engine parts in there. Gives you a real sense of his early struggles.
Amazing. And later in life.
Well, his final home, Heathfield Hall near Birmingham, is gone. But incredibly, the entire contents of his attic workshop tools, chemicals, models, everything were carefully packed up and moved to the Science Museum in London.
You can see his actual workshop.
The whole room, preserved. It's an incredible time capsule. And of course, you can see the engines themselves. The big Smethwick engine from 1779 is at the Think Tank Museum in Birmingham. And Old Bess, one of the earliest Boulton and Watt engines from 1777, is also in the Science Museum. And don't forget his social circle, the Lunar Society. Meeting regularly with Boulton, Joseph Black, Priestley, Erasmus Darwin, he was plugged into the absolute forefront of science. That access must have been invaluable.
So, wrapping this up, James Watt, undeniably brilliant, clearly essential to the Industrial Revolution. But his success wasn't solitary. It depended heavily on luck, on Boulton's capital and business sense, and Wilkinson's specific manufacturing skill.
Right. And his own cautious personality, his flaw, actually became a virtue in practice, ensuring a safe, widespread rollout of steam power, even if it temporarily slowed down the next technical leap.
He accelerated the revolution by ensuring it didn't blow up in everyone's faces, literally.
You could put it that way. He was the necessary stabilizing force. The SI unit of power, the watt, recognizes that huge transformative impact. It's about the momentousness, the sheer scale of change he and Boulton unleashed, more than just the invention itself.
Which leaves us with a final thought for you, our listeners, to chew on. We know Boulton and Watt used their long patent monopoly aggressively. They suppressed rivals, like Jonathan Hornblower with his potentially superior compound engine. They deliberately held back high-pressure steam. So here's the question. Despite enabling the safe adoption of steam, is it possible that, purely in terms of technical progress, their 25-year dominance might have actually had a net negative impact overall, delayed the future even while building the present? Something to think about.